Analyzing rational functions are really nice, especially when you have a denominator that has to the power of 1. Look at this, x to the power of 1. Gee, those linears are just really, really easy to figure out, especially when you're trying to figure out the vertical asymptotes and the non-permissible values. But they're not always going to be that pretty. Look at this one. Look at the denominator on that one. That's got a square in it. Guess what, folks? You have to remember how to factor these things. That becomes vitally important. So remember, when you're trying to figure out the vertical asymptote, you have to find the non-permissible values of the function. And that happens when you look at the denominator. That denominator being x squared minus 4. And if you look here, it says just factor it as if this was a y equals to 0. So we're going to let this say 0, but we're going to say because it's non-permissible, that denominator cannot equal to 0. Aha! So we start factoring this, and we realize a couple of things here. We realize that we have to know all of our factorization that we learned in Math 10 and Math 20. So check it out. Look at this. If you factor this, you recognize this is a difference of squares. So this is an x minus 2 and x plus 2, and you realize that they cannot be equal to 0. So if you solve each one of them independently, you'll find out that this is x cannot equal to 2, and this one here, x plus 2 cannot equal to 0. This means x cannot equal to minus 2. So you've got vertical asymptotes then at x equals to 2 and at x equals to minus 2. And looking at the graph here, that's exactly what we have. Look at our vertical asymptotes. Da-da-da-da-da-da-da and da-da-da-da-da-da-da-da-da-da-da-da. Beautiful. Excellent. But the question also comes up then is this. How do you determine this horizontal asymptote here? Okay? Well, there's a couple little tricks that you have to kind of know and have to understand, and they're going to be summarized on this slide. Okay? Boom. It matters the degree of the denominator and of the numerator. What do I mean by that? Check this out. If the degrees are equal, so in other words, if I have an x squared plus 5x, and on the bottom I have a 3x squared minus 2x, like this. If these highest degrees are equal, it's very, very simple. All you have to do is divide the coefficients. That would have a horizontal asymptote of 1/3. Simple, really, really simple. Look at this again. Look, here's one here. This has got a 3x minus 4 over a 2x minus 1. These degrees match. There's your horizontal asymptote of 3/2. Real easy. And da-da-da-da-da-da-da-da-da. There's your 3/2. Isn't that pretty? So now you look at the bottom here for your vertical asymptote, and it's kind of a combination of the two, right, that determine the horizontal asymptote. Now, there is another one, though. What if the degrees, okay, are like this one here on the right? What if the degree of the numerator is less? What do I mean by that? Anything. For example, you look at something like this. You have an x plus 5 over an x squared minus 2. Look how this top numerator is less than that. Okay? So guess what happens? Horizontal asymptote is always going to be 0. Ask the math gods when you see them. It's actually quite cool. So you got two scenarios so far. Up here, they're equal. Up here, the numerator is less than the denominator. So then I got a question to ask you now. What happens if the numerator is bigger than the denominator, like in this case? Well, this is a little bit of extra. I'm going to show you some extra. This is not part of the course, but they actually call this an oblique asymptote. The best way to do this, show this on your calculator, folks. Don't waste your time. But if you really want to know, I'll show you how to do this. Remember, this is just division. Okay, so x plus 1, right, equals to 0. Bring it over. You got x minus 1. Do a synthetic on this. Minus 1. There's your synthetic. But don't forget, this is x squared, which means you got a 1. But you have no x, so you have to have a 0 placement holder. And this is minus 4. Doing a quick synthetic division, That becomes 1. 1 times minus 1 is minus 1. So that's minus 1 plus 0 is minus 1. Minus 1 times minus 1 is 1. This gives you minus 3. There's your remainder. But see this right here? That is 1x minus 1. That is your equation of your oblique asymptote. Oh my goodness. Rise of 1, run of 1, intersect at minus 1. So there's minus 1. Rise of 1 minus 1. Or sorry, rise of 1, run of 1, up 1 over 1, boom, you're going to get an oblique asymptote that looks something like that, and that's how it works. And you notice that the graphs come close to it, but never touch it. That's how this works. That's just so much more fun. This is so much fun. I love this stuff. Okay, so what we're going to do in the next podcast then is I'm going to play around with these things. I'm going to show you another type of thing that could happen. All right, so we can figure out now the vertical asymptotes, the horizontal asymptotes. We're good, right? Okay, stay tuned.